Hello everyone. More on division of radical expressions. In this video we'll learn to rationalize the denominator of a radical expression. When a radical expression appears in a denominator, it can be useful to find an equivalent expression without a radical in the denominator. That means we need to get rid of the radical expression from the denominator. This procedure is called rationalize the denominator. Rationalize the denominator. We carry this out by multiplying by 1. As we know that 1 means 2 out of 2, 3 out of 3. Any number divide by itself. Radical 3 divided by radical 3 and so on. So how can I get rid of radical if I have radical 3 here? How can I make it 3? So to make it 3 we need to multiply by radical 3. Why? Because radical 3 times radical 3 is radical 9 and radical 9 is 3. Okay. If I have this expression, how can I make it third root of 3? How can I make it 3? This is third root, not square root. So if you say I'll multiply by third root of 3, we will get third root of 9, and we don't have cube root of 9. So how can I make it 3? So I have to make it cube root of 27. And how can I make it cube root of 27? So multiply by cube root of 9. Okay, now let's start. First example, rationalize the denominator. Radical 7 over 3. So first let us distribute radical over each term. So we have here radical 7 over radical 3. Now we have radical expression in denominator, so we have to get rid of this radical by multiplying numerator and denominator by the same number. So we'll multiply by radical 3 in denominator and radical 3 in numerator. Now let us multiply radical 7 by radical 3 is radical 21. Radical 3 times radical 3 is radical 3 squared, so equal radical 21 over 3. Now we have integer in denominator, we don't have any radical in denominator. Another example, third root of 7 over 25. So first we need to distribute this root, so third root of 7 over third root of 25. How can I get rid of third root here? So first we know that 25 means 5 times 5. So we have here 2 5, so we need to make it 5 to the power of 3. How can we make it 5 to the power of 3? So multiply by another 5. And if we multiply denominator, so we must multiply numerator by the same number, and then continue. Multiply third root of 7 times third root of 5, it will be third root of 35. And in denominator we have third root of 5 to the power of 3. Now we have third root of 35 over 5. Another example, square root of 2a over 5b. So first we have to distribute square root here. So we have a square root of 2a and we have a square root of 5b. To get rid of square root here, we need to make 5 to make it 5 to the power of 2 and make it b to the power of 2. How can I make then 5 to the power of 2 and b to the power of 2, so I have to multiply by the same, so radical 5b and here radical 5b. Now let us multiply numerator and denominator, so we'll have radical 10ab over radical 5 square b square. Now we can get rid of radical, so we have radical 10ab over 5b. Another example, rationalize the denominator third root of a over third root of 9x. So first, before we start, we have to know that here this is third root. So third root, so we have to have a cube number under this radical. So 9 means 3 to the power of 2, and here x means x to the power of 1. We need to make both of them 3 to the power of 3 to the power of 3, x to the power of 3. So what is the remainder? So to make it 3 to the power of 3 and x to the power of 3, so we need here 3 and we need here x to the power of 2. Now let us multiply. Equal to third root of 3a x squared over third root of 3 to the power of 3 x to the power of 3. So equal to third root 3a x squared over 3x. Another example, rationalize the denominator 3x over fifth root of 2x to the power of 2y to the power of 3. We have here fifth root, the index is 5, so we have to make under radical all to the power of 5, so we need to change it to be 2 to the power of 5, x to the power of 5, y to the power of 5. How can I change all of them? So we need to multiply by fifth root. Here we have 2 to the power of 1, so we need 2 to the power of 4. X to the power of 2, so we need x to the power of 3. Y to the power of 3, so y to the power of 2. And if we multiply denominator, we must multiply numerator by the same expression. So 2 to the power of 4, x to the power of 3, y to the power of 2. Now, let's continue multiplying. We have here 3x, fifth root, 2 to the power of 4 is 16, x to the power of 3, y to the power of 2, all over. Now we can get rid of the exponent, so 2xy, and we can simplify here numerator with denominator, so the expression will be 3 fifth root 16 x to the power of 3 y to the power of 2 all over 2y. Okay, rationalize when there are two terms in denominator. To rationalize when denominator contains two terms, so we have to multiply by the conjugate. The conjugate process comes from difference of two squares. When I have a minus b, and if I multiply it by a plus b, I'll get a square minus b square. So if I have radical 3 minus 2 and I multiply it by radical 3 plus 2, so I get radical 3 times radical 3 is radical 3 to the power of 2 minus 2 times 2 is 2 square. So it will be 3 minus 4 equals negative 1. That means we don't have any radical now. Now, if I have this expression in denominator, like this one, 3 over x plus radical 7. How can we get rid of radical here? So we need to multiply by conjugate. Multiply by conjugate. So the conjugate of denominator here is x minus radical 7. Same expression with opposite operation. Now multiply numerator and multiply denominator. So we can multiply 3 by x minus radical 7 and multiply denominator here. We have difference of two squares, x square minus radical 7 square. So we will have here 3 times x minus radical 7 over x square minus 7, and now we don't have any radical in denominator. Okay, another example. Rationalize denominator 4 over radical 3 plus x. So we need to multiply by conjugate radical 3 minus x times radical 3 minus x. Now multiply numerator. So it will be 4 times radical 3 minus x. And now by logic, radical 3 plus x times radical 3 minus x. We use conjugate to get rid of radical, so it will be 3 minus x. And now we can distribute 4 over each term, so it will be 4 radical 3 minus 4x over 3 minus x squared. Another example. Rationalize denominator 4 plus radical 2 over radical 5 minus radical 2. So we need to multiply by conjugate. It will be radical 5 plus radical 2, and in numerator radical 5 plus radical 2. Now we have to multiply numerator and multiply denominator. When we multiply denominator, we will get rid of radical, so it will be 5 minus 2. And now we have binomial expression times binomial expression, so we can use distributive multiply first by second expression, multiply second term by the second expression, so it will be 4 radical 5 plus 4 radical 2 plus radical 2 times radical 5 is radical 10, radical 2 times radical 2 is 2 all over 3. So we can keep it like this because we don't have any like terms. That's it. Thank you very much. Goodbye.